For Monday's lesson, we are going to continue to look at probability. You're going to need something to write with and something to write on. Homework tonight is Module 5, Lesson 3, or Imagine Math. Just keep in mind, you need to check with your individual tracker and follow that as a roadmap to the assignments you need to complete for the week. Today we are dealing with what are called equally likely outcomes. Today, you guys can calculate theoretical probability and use that probability to make accurate predictions. You know you have this when you score 80% or higher on today's quizzes involving equally likely outcomes. And our standard is 7 SPC 5, which is just our basic understanding of probability. Now, this was on the slide on both Thursday and Friday last week. By the way, you guys started off really strong on average or overall with the chance experiment probability video. So I want you guys to keep up that momentum throughout this week because you have a good foundation with last week. Probability, as a reminder, is the likelihood that something will happen, and it's generally written as a value from 0 to 1. You can also write these as ratios or fractions and also as percentages. And we've been dealing with this probability scale consistently ever since we started on Thursday. Remember, 0 is impossible. Anything but greater than 0 but less than a half is unlikely. And anything greater than a half but less than 1 is likely. And then 1 is certain. It's like 100%. And a half can be referred to as equally likely or just as likely as not, because that's a 50-50 type situation, like flipping a coin. We're going to come back to this question. So I want you to think of this as we go through the lesson. Betty and Carl will conduct an experiment. They will flip a coin 100 times and record the result of each flip. What should they expect the result of their experiment to be? Justify your answer. So I want you to think about that. And we are going to come to that towards the end. So hopefully you have some kind of prediction in your mind. We are going to start, or we are going to now take a look at a video.
How can you use the probability of an event to make a prediction? Think about this question during the lesson. Talia and Yoshi design a game for the school fair. Contestants spin the pointer and win a prize if it lands on either of the 2 red sections. How can Talia and Yoshi determine how many people are likely to be winners if 500 people play their game? They can determine the number of people using probability. How can you use probability to predict the number of winners?
So we are going to basically expand these out to 500 separate trials to determine how many of those 500 would, based on an estimate, in theory, right, would land on one of those win spaces. So what we're going to have to do here is we're going to first have to find the probability of, in general, the theoretical probability of this spinner and landing on the 2 red sections. Then what we're ultimately going to do is scale that out to 500 total spins.
The first step is to determine the total number of possible outcomes from one spin of the pointer. There are 16 sections that are all the same size. There are 2 sections of each color. The pointer could land on any of the 16 sections, so there are 16 possible outcomes. Which outcome is most likely?
Select your answer.
Now, for more to one section to be more likely than the other, you'd have to be in a situation where one color covers a greater percent of the area than another. Now, red is 2 out of 16, and we were already told each of these are equally likely in terms of their size. So we got 2 red, 2 yellow, 2 green. So it's none of these. One isn't more likely than the other. They're all equally likely here.
Each section is the same size, so the 16 possible outcomes are equally likely. Because because you know all the possible outcomes, you can find the theoretical probability of an event, such as the pointer landing on red. The letter P represents theoretical probability. An event is a single outcome or group of outcomes. The probability of an event is the number of favorable or desired outcomes divided by the total number of possible outcomes. In this situation, the event is the spinner landing on red. The probability of landing on red is equal to the number of red sections on the spinner divided by the total number of sections. There are 2 red sections and 16 total sections, so the probability is 2/16, or 1/8. The theoretical probability that a contestant will win this game is 1/8, or 12.5%.
Before we move forward, I just want to summarize this here. To find the probability of any event, and it's written in this notation, which was covered last week, P parentheses what you're looking for. Whatever you're looking for, which is referred to as favorable outcomes, goes on the top. In this case, we're looking for the probability of red. So there were 2 red sections. What goes in the denominator is the total possible outcomes. And because there were 16 different sections, that goes in the denominator. And at that point, they just simplified the fraction here by dividing the numerator and denominator by 2 to get 1/8. And 1/8 as a percent is 12.5%. You can always pose a probability as a fraction of percent, or we can move this decimal point over to and pose this as a decimal of 125 thousandths.
Our last step is to use proportional reasoning to predict the number of likely winners, which will represent with the variable W. The probability of choosing red, or 1/8, is equal to the ratio of W to the total number of contestants, which is 500. Multiply both sides of the equation by 500 and simplify. So W equals 62 and 5/10. Of the 500 contestants, about 62 are likely to be winners.
So what happened there is we're basically scaling that singular probability of 1/8, which means 1 spin out of 8 total spins is a winner, and you're scaling it up to 500 total spins. So you can either divide to find the scale factor, or what happened here is they multiplied out the 500 basically times 1 and then divided it by 8, which is what's happening here to get this 62.5. But the first step in making that prediction is you find the probability, a theoretical probability of that event happening, and then you just use proportional reasoning to scale it out to whatever number you're looking for. Now, just a reminder, when you guys see this notebook and pencil on the screen, the expectation is you are writing these down. It's going to benefit you. Writing notes leads to longer, long-term memorization of the material rather than just listening and looking. Writing down will cause you to remember it more, and they serve as a reference when you need help. So write down. I also don't mind if you write down more than when these pencil and notebook is on the screen. So for instance, if you took notes during the video, that's fine, but you should for sure at minimum take notes when you have your notebook and pencil on the screen. All right, so let's look at this example here. Ghazal is playing a game with a spinner. The spinner has 12 equal-sized sections, okay, labeled 1 through 12. She wins a prize if the pointer lands on 3, 5, or 7. Calculate the probability that Ghazal has a winning prize. Now, some of us are visual learners, and if you are struggling to understand this question, a lot of times it helps to draw a picture. So we have our 12 equal size section spinner down here on the left. Now, she wins if she lands on basically 3, 5, or 7. Now, we are looking for the probability of 3, 5, or 7. And you're going to notice me more and more use this notation. What I'm looking at for the numerator is the number of favorable outcomes. So how many sections are 3, 5, or 7. And that is 3 of them. We got 3, we got 5, we got 7. And then what's going to go in my denominator is just how many total sections there are, which is 12, right? You got 1, 2, 3, all the way up to 12. So this is her probability, but in general, we should work to simplify our probabilities. And that simplifies to 1/4 or 25/100 if you want to write it as a decimal, or 25%. So basically here, Ghazal has a 1/4 shot at winning. What does that mean? That means in theory, theoretical probability, in theory, she would win a prize 1 out of every 4 times she spun, or 3 out of every 12 times. We could extend this out, and if we know she wins 1 out of every 4 times, we could make a prediction and say, how many would she win in 44 times? Or how much would she be expected to win? Keep in mind, this is theory. This is a scale factor of 11, so she would be expected to win 11 out of 44 times, okay? But finding that original probability, which is right here, allows us to make predictions about later probabilities. Let's take a look at this example. Keep in mind, you're going to pause the video and write this down. The probability that student guesses the correct answer to a 5-choice multiple choice question is P of correct is 2/10. And that means you have a 1 out of 5 shot, which is 2/10. How many correct answers should a student expect to guess on a test with 95 5-choice multiple choice questions? All right, I'm going to show you a few ways to do this. One way is setting up our proportion. This is 2/10. That means 2 out of 10. Okay? I am going to simplify that to 1/5. So when I go to set up my proportion, I know every time there are 5 questions, I get 1 out of 5. It's not asking about 5 questions. It's asking how many for 95. So from here, you can cross multiply and then divide. Or what you can do is you can find the scale factor here by dividing. And this is 19 times bigger. So what does that mean? Well, that means I have to also multiply my numerator by 19. So my answer here is x equals 19. Now I'm going to write this in a complete sentence, and I should have wrote the first one in a complete sentence too. A student should expect to get 19 questions correct on a test with 95 5-choice multiple choice questions by just guessing. Now, these are theories. When you guys actually, or if you actually do the experiment and just guess on like a test you have no idea about, you may not get 19 correct. You may get more, you may get less, but in theory, you should get 19. Now, obviously, the number of questions go up that you get correct based on you studying and being prepared. But this is just saying if you have no idea what you're doing and you're randomly guessing, you're going to get about 19, give or take, right, based on just the probability. Now, another way to do this, we know this is our probability. You can just take that value as a decimal and you can multiply it because you basically want to find a 1/5 or 2/10 of 95, and that gets 19. So that's just another strategy to do it because you want, like I said, 2/10 or 1/5 of 95, and that gets 19. So I want us to go back to this question. Betty and Carl will conduct an experiment. They're flipping a coin 100 times and recording the result of each flip. What should they expect the results of their experiment to be? Well, the probability of getting, and let me write this neatly here. The probability of getting heads is 1/2. Just like the probability of getting tails is 1/2. If you scale both of these, and it doesn't matter because they're the same fraction. If you scale both of these all the way up to, instead of 2 flips, 100. This is times 50, so the numerator has to be times 50. So what you would predict here is that if you flip a coin 100 times, you'd expect half of them, 50 of them, to be heads, and 50 of them to be tails. Now, you're probably already thinking that that probably won't happen. Yeah, this is called theoretical probability. So, in theory, what should happen? We're not conducting experiments to see what actually happened, which is called experimental probability. We're just saying, based on the numbers and based on the idea of theory, what should happen? And the likelihood of you getting close to 50 of each heads and tails is likely. You may get like 51-49 or, 55-45, or you may even get 60-40, but you're going to get fairly close to that 50-50 split more likely than not. And the more times you flip, this is just a rule of probability, the closer you're going to end up getting to this theoretical probability. The more trials, the more accuracy in general. So, theoretical probability. You can determine the theoretical probability of an event by writing the number of favorable outcomes, meaning what you're looking for, over the total number of possible outcomes. So, for instance here, if I'm looking to land on red or orange, that is 2, and then the total is 8, so that would be 2 out of 8. And you can make a bunch of probabilities based on this spinner here that this guy is playing with over here on the right. Now, if you need additional help, this Khan Academy video discussed a little bit the difference between experimental probability and theoretical probability. You can also just Google probability, guys. There's hundreds, if not thousands, if not tens of thousands of resources out there to help. You guys just got to reach out and use them. Today's goal, you guys are going to complete a Quizizz on equally likely outcomes. I want us as a class to try to beat what we got last time. Okay, so increase your percentage, complete your assignments, and you guys can be eligible for not only game night, but money in the form of gift cards, like legit money that you can buy things with through gift cards. So complete your Quizizz on equally likely outcomes. What I don't want to see is you guys only use 1 or 2 attempts and not exceed that 80%. You need to persevere and you need to use all 3 tries if necessary. If you need help, as always, reach out for support.